right, these are some problems that I've just chosen off of section 9.4 for Algebra 1. So I thought I would start by just doing some that have decimals in it, like number 15. I had put 20 here, but I changed my mind. Okay, so 15, 0.02x plus 0.03y is equal to 9, and 0.02x plus 0.05y is equal to 13. Now, first of all, if you look at this, you might just not want to mess with the decimals. You could do the math with the decimals in it. It's not like you couldn't. But let's say you don't want to, okay? So what you do is you come in here and you're going to multiply. It's in both equations, if you notice. So we're going to do this to both equations just because they both could use it. I'm going to multiply everything by 100. And the reason I chose 100 is, remember, that just moves the decimal place over 2 spots in each one of these terms. And so, like for 9, if I multiply it by 100, I'll have 900. So that makes my new equation 2x plus 3y is equal to 900. All right, now the second one, I'm also going to multiply by 100, but notice I have a 2x in 0.02x in the first two equations when I start. Both of those equations have 0.02x in them. So I would kind of like to get rid of them. Now I could do this in a different step, but if I notice that both of them are positive and I know I need one positive and one to be negative, what I could do is multiply the second one by negative 100. And that way, you know, I get rid of the 2x, okay? So it'll also change the signs. If I multiply by 100, that's going to move that over 2 spaces. But if I'm also multiply by negative, I get negative 2x instead of just 2x. This second term here was positive. It'll be negative 5y instead of just 5y. And then negative 100 times 13 would be negative 1300. You might notice it might have been smarter of me to multiply the first equation by the negative because the numbers are smaller. And if I don't like negative numbers, that could have kept me from having to add with negative numbers now. Okay, but this would work too. Because now if you look, if I add stuff together, the 2x's are going to cancel out. 3y plus negative 5y, or 3y minus 5y, it's all the same thing, okay, is minus 2y. And 900 minus 1300 is negative 400. If I want to find out what y is, I'll divide both sides by negative 2. And I get y is a positive 200. So if I'm looking to write my answer somewhere, I now know my y is 200. My x goes here, my y goes here, and this is going to be where I list my answers. If you write that, that'll help you remember to go back and get the other variable. Now I can do whatever I want to get the other variable x. I could use any equations. I've got 4 to pick from now. I've got the 2 originals, and then I've got the ones, that after I cleaned out the decimal. So I'm going to use the first equation, and I'll do that in a different color just so you can see what I'm doing here. I'm going to pick this equation. 2x plus 3y, well, y is 200, so I'm just going to plug it in instead of rewriting it and using up the space here that I have here, which is diminishing, is equal to 900. Well, that's 2x plus 600 is equal to 900. I'm going to leave that 900 there and let it count for both of those just because I'm out of space. Now, if I want to solve for x, I'm gonna look at this 900 that I wrote kind of slanted is going with the second equation now because I'm just out of space. So I'm going to move the 6. I'm going to try to get x by itself. So I'm going to subtract 600 from both sides. Remember, we add or subtract first. That's going to give me 2x is 300. And if I divide both sides by 2, x would be 150. Remember, you can use your calculator if you want to. So now I know my x value is 150, and I'm done with that problem. I'm going to do 17 because a lot of people still freak out every time they see a fraction. So I know you're out there, and I'm going to try to help you get over that fear here, okay? A half x plus a third y is equal to 4, and 5 halves x minus 1/3 y equal 8. This is kind of a nice problem just because both of the 2 equations that they gave me have a 2 and they have a 3 in the bottom. Oh, wait a second. Yeah, both of them have a 2 and 3 in the bottom, and I could get rid of the fraction, but do you already notice that you have opposites going on here? Maybe we don't need to clear. We could clear the fractions. If I decided to get rid of the fractions before I worked anything else, I could multiply every single thing in both of the equations by 6, and the reason I would pick 6 is you want the smallest thing that both 2 and 3 could go into. If you multiply every single term in both equations by 6, you get rid of all your fractions. It just so happened this time they gave you two equations that had 2's and 3's in both of the denominators in both equations, but usually that doesn't happen. Usually you multiply through by a different number. Okay, well, I might do that. It might be something I consider doing, but I just noticed that I got a plus 1/3 y and a minus 1/3 y, and that they're going to cancel out. Well, if I look at my x's, a half of x plus 5/2 of x would be 6/2 of x. If you remember adding fractions, and you need to because they don't go away anytime in math ever. That's actually 3x, isn't it? 3x is equal to 12 because 6 over 2 is 3. So if I want to get x by itself, I could divide by 3, and I'd have x equal 4. So if I'm writing my answer down, I'll make my brackets. My x goes first. I'm still looking for that y value there. Okay, so I need to find the y value. I think what I'm going to do is I'm not going to be so afraid of fractions. We kind of got to get over it, and here's the problem with some of the 11th graders even having trouble with fractions because they've got so used to clearing them, they don't remember how to do them. So I kind of think it's good to work with fractions every once in a while. I know that x, I'm going to use the first equation. I'll circle it so you see which one I'm using, this one. A half of x, well, x is 4, so we'll plug it in, plus what, go away line, plus 1/3 y is equal to 4. I'm just using that equation and plugging in x. A half of 4 is just 2. 2 plus 1/3 y is 4. I want to get y by itself. The first thing I need to do is add or subtract anything I can. So I'm going to subtract 2 from both sides. That's going to be 1/3 y is equal to 2. And how do you could divide both sides by 1/3, but that looks pretty messy. So if you remember, there's another way to get rid of a fraction when it's in front of a variable, and it's to multiply by the reciprocal. And if I do it to one side, I got to do it to the other side. The reciprocal of 1/3 is just 3, so I didn't have to write it as 3 over 1. I just want you to see, that causes everything to cancel out as 1 over 1 y, which is just y, equal 2 times 3 over 1, same thing as 2 times 3, that is 6. So y is 6. Don't be afraid of the fractions. If you don't like them, you could have done this differently, multiplied everything by 6 to get rid of them, and then canceled out. It would have been fine to do that. But it's good to play with fractions and keep them, in your ability to do, set of skills there. Okay, so I thought I would try to fit another one on here. I thought I would do, we'll start with, let's see, I'm going to do 21 just because it looks harder than 20. You get the choice here of either using substitution or the addition or subtraction method. So let's look at 21. It's 4 times x minus 2y is equal to 8. And x plus 6y is equal to 2. You can choose either one you want to. I'm going to do this as this addition or linear combination, elimination kind of thing. And the reason is, I could get this x right here by itself if I wanted to and do substitution. And if you want to do that, you can. I just prefer elimination because the x's and the y's are on both sides of the equation. I'm going to have to remember to distribute here. So I'll just come down to work here. So that first equation is really 4x minus 8y is 8. And the second equation is x plus 6y is 2. The easiest thing to do to get opposite signs here, if I look at the x's and the y's, what I could do is multiply this second equation by negative 4. It's just an x, so it'd be real easy to multiply it by negative 4. And if I multiply by negative 4, I'll get negative 4x. So let's come down. I'm just going to draw a line between each set of things that I do. So now I'm going to rewrite the two equations again. 4x minus 8y is 8. I'm just writing the first one the way it was. The second one is now negative 4x. Be sure you multiply every term now. Negative 4 times 6y would be minus 24y, negative 24y. And negative 4 times 2 would be negative 8. Okay, so the x's cancel out. Negative 8y plus negative 24y would be negative 32y. And 8 minus 8 would be 0. Yeah, we could say they cancel out, but I need a number over there. Otherwise, I don't have an equation anymore. I have negative 32y equals what? Well, 8 minus 8 is still 0. You learned that math fact, a long time ago, and it's still true. So don't forget that if everything goes away, you fill in with a 0. Well, if negative 32y equals 0 is my equation, if I want to solve for y and I divide both sides by negative 32, 0 divided by negative 32 is just still 0. So y is equal to 0. So I'm going to write my answer here. I'll put my x first and then my y. I just found my y. It was 0. So that's going to be an easy one to plug in. I think what I'm going to do is for plug in y to find x, I think I'm going to try to write that. I'm going to plug it into the second one because it's nice and a simple equation, isn't it? So it's x plus 6y, except y is 0. I'll plug it in, is equal to 2. So that's x plus 0 is equal to 2, which is just as x is 2. So there's my solution right there, 2, 0.